January 30th, 1944. Anzio Beachhead, Italy. The bunker was built to survive a war. 4 feet of reinforced concrete sealed the structure into the hillside, layered with steel and earth. Inside, the air was heavy. Dust clung to every surface. Instruments hummed softly under dim light. Through a narrow periscope, a German officer scanned the distant Allied lines stretching across the coastal plain. There was no movement, no visible threat. For months, this position had endured artillery, air raids, and relentless pressure. Nothing had broken it. Then the ground shifted, not gradually, not like distant shelling. This was different. A sudden, violent compression of air and earth. The bunker trembled as if struck from beneath. A fraction of a second later, the impact arrived. Concrete did not crack. It vanished. Where a fortified position had stood seconds before, there was now only a rising column of dust and debris. Steel supports twisted. The interior collapsed inward. 30 men disappeared with the structure that had been designed to protect them. No warning, no sustained bombardment, a single round. Beyond the horizon, miles away and unseen, an American gun crew prepared their next shot. This was not ordinary artillery, and on that day, without announcement or precedent, the rules of fortress warfare began to collapse. The illusion of impenetrable defense. Long before the guns fired at Anzio, the foundations of this moment had been laid in concrete and steel across Europe. Between the wars, military planners on both sides studied the lessons of World War I. The conclusion seemed clear. Firepower had grown faster than maneuver. On defensive positions, when properly constructed, could absorb punishment that would shatter attacking forces. The future battlefield, many believed, would belong to those who could build the strongest fortifications. Germany embraced this idea with precision. By the late 1930s, the German army had refined bunker construction into a science. Reinforced concrete structures, often several feet thick, were designed to withstand direct hits from heavy artillery. Steel reinforcement grids distributed shock. Earth and rock were layered above for additional protection. Many positions were built into hillsides or reverse slopes, hidden from direct observation and shielded from aerial bombardment. These were not temporary field defenses. They were engineered strongpoints, intended to dominate terrain and survive sustained attack. From the Atlantic coast to the Italian mountains, this philosophy shaped German defenses. In Italy, after the Allied landings, entire ridgelines were transformed into interconnected fortress systems. Observation posts, machine gun nests, and command bunkers were positioned to support each other, creating overlapping fields of fire. Every approach was covered, every weakness reinforced. At Monte Cassino, ancient stone and modern concrete merged into a defensive network that held Allied forces for months. Along the Gustav Line, German engineers used terrain as a weapon, embedding bunkers into mountainsides where conventional artillery could barely reach. Even when bombs struck, many of these positions remained intact. The assumption was simple. If a bunker could survive the heaviest shell the enemy possessed, it could not be easily destroyed. For a time, this assumption held true. Allied forces advancing through Italy encountered a problem they could not quickly solve. Infantry assaults against fortified positions resulted in heavy casualties. Air power, though destructive, lacked the precision to eliminate individual bunkers without leveling entire areas. Standard artillery could damage structures, crack surfaces, and suppress defenders, but often failed to destroy the position completely. A bunker that survived the initial bombardment could resume fire within minutes. This created a cycle. Attack, suppress, advance, stall, repeat. Each failed assault reinforced the same conclusion. These fortifications were working. German defenders, many of them experienced veterans, grew confident in their protection. Inside the bunkers, there was a sense of security. Fragile, but real. The walls were thick. The engineering was sound. The enemy could be heard, but not always felt. Even under bombardment, survival seemed likely. And that belief became part of the defense itself. Because fortifications are not only physical structures, they are psychological anchors. They give soldiers a place to hold, a position to trust, a reason to remain under fire. As long as the bunker stood, the line held. But beneath this apparent strength, a critical weakness remained untested. The entire system depended on a single assumption, that no weapon existed capable of reliably destroying these structures from a distance. For years, that assumption had been correct. Standard field artillery lacked the mass and penetrating power. Railway guns, while capable of immense destruction, were slow, immobile, and impractical for fluid battlefields. Air-delivered bombs required accuracy that was difficult to achieve against concealed targets. There was a gap between what was needed and what existed, and in that gap the German defensive doctrine settled into certainty. By 1943, as Allied forces fought their way through Italy, this certainty hardened into expectation. Bunkers were reinforced further, positions were expanded. Engineers continued to build, confident that the fundamental principles still held. Concrete, properly applied, could stop anything. But elsewhere, far from the front lines, a different conclusion had already been reached. American planners had studied the same problem and arrived at a very different answer. The question was no longer how to endure fortifications. It was how to eliminate them completely, and the solution was already being built. The weapon designed to break concrete. The realization did not come from the battlefield. It began in analysis. In 1940, as war expanded across Europe, the U.S. Army Ordnance Department conducted a detailed study of modern fortifications. Reports from Poland, France, and early German campaigns revealed a pattern. Reinforced concrete bunkers were no longer vulnerable to standard artillery. Even heavy guns could damage them, but not reliably destroy them. The conclusion was direct and uncomfortable. The United States did not possess a field weapon capable of defeating modern European fortifications. Existing artillery systems, including the widely used 155mm guns, lacked the necessary combination of mass, velocity, and penetration. They could suppress, they could harass, but they could not guarantee destruction. Against deeply embedded bunkers, this limitation translated into prolonged battles and rising casualties. The requirement that followed was ambitious. A new weapon was needed. It had to deliver overwhelming force in a single strike. It had to penetrate thick, reinforced concrete before detonation. And it had to do so with enough accuracy to engage individual targets, not entire areas. At the same time, it could not be a static system. Unlike the massive railway guns of the previous war, this weapon had to move with the army. It had to be deployed where needed, not fixed to tracks or permanent emplacements. Mobility, even at a limited scale, was essential. From these constraints, the concept of a super-heavy mobile howitzer emerged. Development took place at Watervliet Arsenal in New York. So a site with decades of experience producing large-caliber artillery. Engineers faced a fundamental challenge. Increasing shell size increased destructive power, but also increased weight, recoil, and logistical complexity. Every solution introduced a new problem. A larger barrel required stronger support structures. Greater recoil demanded deeper stabilization. Transporting such a weapon required specialized equipment. The system could not simply be scaled up. It had to be re-engineered entirely. The result was the M1 240mm Howitzer. At first glance, it did not resemble a conventional field gun. The barrel alone measured over 10 meters in length. In firing position, the entire system weighed more than 30 tons. The weapon required a crew of 14 men, along with cranes and transport vehicles, to assemble and operate it. Deployment was not immediate. It could take hours to prepare a firing position. A recoil pit had to be dug. The carriage assembled, the barrel positioned and aligned. Every step demanded precision. This was not a weapon designed for rapid maneuver. It was designed for deliberate destruction. The projectile it fired reflected that purpose. Each shell weighed approximately 360 pounds. Its mass alone gave it enormous kinetic energy in flight. But the true effectiveness came from its design. A hardened steel cap allowed the shell to penetrate layers of concrete before detonating. A delayed fuse ensured that the explosion occurred inside the structure, not on its surface. This transformed the nature of impact. Instead of chipping away at the exterior, the shell entered the bunker and detonated within its core. The resulting shock waves propagated through the concrete and steel reinforcement, creating internal fractures that caused entire sections to collapse. Structures did not simply break, they failed from within. The weapon also offered range. It could strike targets more than 20 kilometers away, well beyond visual contact. Combined with forward observers and emerging fire control systems, this allowed the gun to engage specific positions with increasing accuracy. A bunker could be identified, plotted, and eliminated without ever seeing the weapon that destroyed it. This separation between cause and effect would become one of its most unsettling characteristics. Production began in late 1942. Initially, only a small number of units were manufactured, but as the need for such a weapon became clear, output increased steadily. By 1944, multiple battalions were equipped and trained. Each gun represented a significant investment in resources, materials, and time. But the United States possessed something equally significant: industrial capacity. Where other nations struggled to produce limited numbers of specialized weapons, American factories scaled production. Ammunition, spare parts, transport vehicles, everything required to sustain the weapon in combat was produced in volume. The howitzer was not an isolated system. It was part of a larger network of logistics, coordination, and supply. This system ensured that when the weapon was deployed, it could operate continuously. By early 1944, the first units were ready for combat. They were assigned to artillery battalions and shipped to Europe. Their destination was not chosen at random. They were sent to a front where fortified defenses had already stalled in advance, the Anzio beachhead. Their Allied forces had been contained within a narrow perimeter, facing German positions entrenched in the surrounding hills. The terrain favored the defender. The bunkers were well constructed. Previous attempts to dislodge them had failed. It was the ideal environment to test a weapon designed for a single purpose: to destroy what could not otherwise be destroyed. When the first M1 240mm Howitzers arrived, they were positioned carefully, assembled methodically, and integrated into the existing artillery network. Forward observers identified targets. Coordinates were calculated, firing solutions prepared. There was no spectacle, no announcement, only a new capability waiting to be used. And when the first round was fired, the outcome would challenge every assumption the defenders had relied upon, because for the first time the protection of reinforced concrete would be measured against a weapon specifically built to defeat it. The physics of destruction. At its core, the effectiveness of the M1 240mm Howitzer was not simply about size. It was about how force was delivered. A 360-pound shell, traveling at high velocity, carried immense kinetic energy. When it struck reinforced concrete, that energy was concentrated into a small area. The hardened steel cap allowed the projectile to resist shattering on impact, enabling it to penetrate several feet into the structure before detonation. This sequence was critical. Surface explosions could damage a bunker. Internal explosions could destroy it. Once inside, the delayed fuse triggered a blast that expanded outward through confined space. Shockwaves reflected off steel reinforcements, multiplying stress within the structure. Concrete, strong under compression but weak under tension, fractured in multiple directions simultaneously. The result was not a gradual collapse. It was sudden structural failure. Entire sections of bunker roofs could lift and disintegrate. Walls cracked from within. Support beams twisted under pressure they were never designed to absorb. Even near misses had consequences. The ground shock alone could destabilize foundations, causing partial collapses or rendering positions unusable. This was not suppression fire. It was targeted demolition, delivered at range. The crew behind the weapon. Operating such a system required more than machinery. It required coordination. Each 240mm howitzer was served by a crew of 14 men. Every position had a defined role, and every action depended on timing. There was little room for error. The process of firing began long before the trigger was pulled. Ammunition handlers prepared the projectile, guiding it into position using a crane system. The shell, weighing over 160 kilograms, could not be lifted manually. It had to be aligned carefully with the breech. Once in place, it was rammed into the barrel using mechanical assistance. Behind it, powder charges were loaded in separate increments. The number of charges determined range. Too few and the shell would fall short. Too many and pressure inside the barrel could become dangerous. The gunner and assistant gunner adjusted elevation and direction based on firing data received from command. Small adjustments at the gun translated into large differences at the target. When everything was ready, the order was given. The firing itself was violent. The concussion from a single round could be felt throughout the crew's bodies. The ground shifted. Air compressed sharply against the chest. Even with protective measures, repeated exposure led to fatigue and long-term hearing damage. After each shot, the process began again. Under sustained operations, crews worked in rotation, maintaining efficiency while managing exhaustion. There was no distance from the weapon's effects. Every round fired was physically experienced by those operating it, and yet the crew rarely saw the result. They fired into coordinates, not targets. The system behind the shot. What made the 240mm howitzer truly effective was not just the gun or the shell. It was the system that guided it. By 1944, the U.S. Army had refined a method of artillery coordination centered around the fire direction center. This system allowed multiple elements, observers, analysts, and gun crews, to function as a unified network. Forward observers played a central role. Positioned near the front lines, often with infantry units, they identified targets through binoculars or scopes. These were not general areas. They were specific structures, bunkers, observation posts, fortified positions. Once identified, the observer transmitted coordinates via radio. At the Fire Direction Center, these coordinates were processed. Personnel calculated firing solutions using maps, range tables, and meteorological data. Wind speed, air density, elevation, all factors were considered. The goal was accuracy, not volume. Within minutes, instructions were relayed to the gun crews. Elevation, direction, charge. Everything was calculated to ensure that when the shell arrived, it would land as close as possible to the intended target. This system enabled a new form of artillery use. Instead of saturating an area with shells, individual targets could be engaged with precision. A bunker could be selected, calculated, and destroyed without affecting surrounding positions. It also enabled coordination across multiple batteries. Through a technique known as time on target, different guns could fire at calculated intervals so that their shells arrived simultaneously. From the perspective of those on the receiving end, there was no buildup, no warning sequence, only sudden, simultaneous impact. This combination of precision, coordination, and delayed effect created a form of artillery that behaved differently from anything previously experienced. It was not defined by noise or duration, it was defined by outcome. And for those facing it, the outcome was becoming increasingly clear. The weapon had been designed, the crews were trained, the system was in place. What remained was the perspective of those on the receiving end, and how quickly their confidence began to erode. The German perspective. For German defenders, the first encounters with 240mm fire did not immediately make sense. They had faced artillery before, heavy artillery. Soviet barrages on the Eastern Front had demonstrated overwhelming volume. Allied naval guns had delivered massive shells from offshore. Bombing raids had flattened entire areas. But this was different. The destruction came without buildup. There was no sustained barrage to signal danger, no pattern of incoming fire. A bunker could remain untouched for hours, even days, and then, without warning, it would be gone. Entire positions disappeared between one moment and the next. Reports from German units began to reflect confusion. Some described the impacts as earthquakes. Others noted that even heavily reinforced structures, previously considered secure, were no longer reliable. The shock was not just physical, it was conceptual. The assumption that had defined their defensive strategy, that concrete provided safety, was no longer consistent with reality. Captured war diaries and post-battle reports described a growing reluctance among troops to occupy forward bunkers. Some units rotated positions more frequently, others avoided enclosed structures altogether, and are choosing shallow field positions over reinforced shelters. This was not standard behavior for trained defensive troops. It indicated a shift in trust. Once that trust was weakened, the effectiveness of the entire defensive system began to decline. Tactical impact on the battlefield. The presence of the 240mm Howitzer altered how engagements unfolded. Previously, fortified positions required a sequence of actions to neutralize. Artillery would suppress, infantry would advance, engineers might be brought forward to place charges or clear obstacles. Each step carried risk and consumed time. With the introduction of super-heavy artillery, that sequence could be shortened. A forward observer identified a bunker. Coordinates were transmitted. Within minutes, a shell could be delivered with sufficient force to eliminate the structure entirely. This removed the need for close assault in many cases. Infantry units no longer had to approach every fortified position directly. Instead, they could wait for the artillery to clear the obstacle. This reduced exposure and, in many instances, lowered casualty rates during attacks on heavily defended areas. It also allowed for selective engagement. Rather than targeting broad areas, commanders could prioritize specific strongpoints that were holding up an advance. Once those points were removed, the surrounding defensive network often became less effective. A single destroyed bunker could disrupt an entire sector. This efficiency changed operational tempo. Advances that might have stalled for days could resume within hours once key positions were neutralized. Defensive lines built on interconnected strongpoints became more vulnerable when those connections were systematically removed. The battlefield was no longer defined solely by terrain and fortification. It was increasingly shaped by the ability to target and eliminate specific elements within that terrain. The psychological dimension. While the physical destruction was measurable, the psychological impact was more difficult to quantify, and often more significant. Soldiers rely on structure and predictability in combat. Even under fire, patterns can be recognized. Incoming artillery usually follows a sequence. There is time to react, to take cover, to assess. The 240mm Howitzer disrupted that pattern. Its rounds could arrive without warning. The time between firing and impact, combined with long range, meant that the first indication of danger was often the explosion itself. There was no audible approach, no opportunity to anticipate. This unpredictability created a different kind of stress. Inside a bunker, a soldier might hear distant artillery and feel relatively secure. But if that same bunker could be destroyed instantly, without prior indication, the sense of safety was undermined. The bunker became uncertain, and uncertainty affects behavior. Accounts from the period describe increased anxiety among troops assigned to fortified positions. Some avoided enclosed spaces, others preferred to remain outside, even under conditions where exposure carried its own risks. The calculation of safety had shifted. A structure designed to protect could now become a point of vulnerability. This reversal had broader implications. Defensive doctrine relies not only on materials and design, but on the willingness of soldiers to occupy and defend positions. If confidence in those positions declines, the effectiveness of the defense is reduced, even if the physical structures remain intact. In this way, the 240mm Howitzer exerted influence beyond its immediate targets. It altered perception. And once perception changed, behavior followed. By the time these effects became fully understood, the weapon had already moved beyond its initial deployment. Its use was expanding across multiple fronts, and in the months that followed, its role would shift from introduction to decisive application, where the cumulative effects of precision, power, and psychological pressure would converge at key moments in the war. Anzio and Monte Cassino, the moment fortresses began to fail. The transformation did not happen gradually. It began at Anzio. Where the battlefield had already reached a stalemate. After the Allied landings in January 1944, forces were confined to a narrow coastal perimeter. German units held the surrounding high ground, constructing fortified positions that overlooked every approach. Observation posts directed artillery fire with precision. Infantry positions were reinforced with concrete bunkers embedded into hillsides. Every attempt to advance met the same result: fire from unseen positions, resistance that did not collapse. The battlefield settled into a static confrontation where both sides understood the terrain and neither could easily change it. Into this environment, the first American 240mm howitzers were deployed. They were not positioned for spectacle. They were placed deliberately, often behind the lines, where their range allowed them to engage targets beyond direct observation. Forward observers identified key German strongpoints, bunkers that had resisted previous attacks, positions that controlled movement across the front. The first engagements were limited: a single bunker, a single shot, then observation. When the first round struck its target, the effect was immediate and unambiguous. A structure designed to withstand heavy artillery ceased to exist. There was no prolonged exchange, no visible degradation over time. It was removed. From that point, usage expanded. Targets were selected based on tactical importance: observation posts, command bunkers, reinforced firing positions. Each was engaged individually. Firing solutions were calculated, adjusted, refined. Within days, a pattern emerged. Positions that had held for months were eliminated in minutes. The numbers, recorded carefully, reflected this change. Dozens of bunkers were engaged. The majority were destroyed. In many cases, only a few rounds were required per target. Accuracy improved with each engagement as crews and observers adapted to the weapon's capabilities. German responses evolved quickly but not effectively. Some units attempted to reinforce existing structures, others relocated to alternative positions. But the fundamental problem remained: if a bunker could be identified, it could be destroyed. This realization spread through the defensive lines. Prisoners taken during this period reported declining confidence. Some described the shells as producing effects unlike anything they had experienced. Others noted that after witnessing the destruction of nearby positions, they no longer trusted their own. The impact extended beyond the physical loss of structures. It affected decision-making. Commanders who had relied on fortified positions to anchor their defense now faced uncertainty. A bunker that could not be guaranteed to survive could not serve as a reliable strongpoint. The interconnected system of defenses began to weaken as individual elements were removed. At Anzio, the shift was measurable. Artillery was no longer simply supporting operations. It was enabling them. By neutralizing key positions, it reduced the need for direct assaults. Infantry units advanced into areas that had previously been covered by defensive fire. Movement, once restricted, became possible. The stalemate began to erode. And the same capability would soon be tested under different conditions. Further south at Monte Cassino, the challenge was not only fortification, but terrain. The Gustav Line had been constructed across mountainous ground, where elevation and natural cover enhanced defensive strength. German forces, including elite paratrooper units, had integrated bunkers into slopes and ridgelines, creating positions that were difficult to detect and harder to reach. Previous Allied attempts to break this line had failed. Airstrikes had caused damage but lacked precision. Conventional artillery could not consistently penetrate the reinforced positions. Infantry assaults faced steep terrain and concentrated fire. The line held. When 240mm howitzers were introduced into this sector, they brought the same principles, but under more complex conditions. The gun positions were established in valleys, often far below the target areas. Instead of direct trajectories, shells were fired at high angles, rising above the terrain before descending onto positions from above. This method allowed engagement of reverse-slope defenses, positions intentionally placed to avoid direct fire. The effect was significant. Bunkers that had been shielded by terrain were now exposed from a different angle. Shells descended almost vertically, striking positions from above and penetrating into their structure. The protective advantage of the slope was reduced. As operations intensified, the howitzers were used continuously. Over extended periods, sustained fire was directed at identified targets. Forward observers, positioned with advancing units, adjusted fire to maintain accuracy. Each successful strike reinforced the same conclusion. Fortified positions could not endure repeated engagement. Post-battle assessments indicated a high rate of destruction among targeted bunkers. In some cases, positions were not physically destroyed but abandoned after near misses, as the perceived risk outweighed the benefit of remaining inside. This distinction was important. The weapon did not need to destroy every structure to be effective, it only needed to make them untenable. At Monte Cassino, this contributed to a broader shift in the battle. Positions that had resisted previous assaults were weakened or removed. Defensive cohesion declined as strongpoints were eliminated or vacated. The line, which had held for months, began to give way. These engagements demonstrated more than the effectiveness of a single weapon. They showed that a specific type of defense, one built on static, reinforced positions, could be systematically defeated under the right conditions. What began at Anzio as a localized application was now becoming a broader capability. And as the war moved forward into Western Europe, that capability would be applied on a much larger scale. against defensive systems that had been built over years and believed to be far stronger than anything encountered before. Normandy to the Siegfried Line, the collapse of fortress warfare. By the summer of 1944, the war in Western Europe had reached a new phase. After the landings in Normandy, Allied forces pushed inland. But progress was slow. The landscape itself had been turned into a defensive system. Hedgerows, sunken roads, and concealed positions allowed German units to create strongpoints that were difficult to detect and even harder to eliminate. Many of these positions followed the same principle seen in Italy: reinforced bunkers, concealed observation posts, reverse-slope defenses. They were designed to survive. Even after massive aerial bombardments, certain positions remained operational. Entire sectors could continue resisting despite hours of air and artillery preparation. The assumption persisted: if properly constructed and concealed, a defensive position could endure. But by this stage, the 240mm Howitzer was no longer experimental. It was integrated. During the breakout operations, including the battles around St. Lo, these weapons were deployed against targets that had resisted other forms of attack. Then forward observers identified positions hidden behind terrain or vegetation. Coordinates were transmitted, firing solutions calculated. Then, without buildup, the strikes came. In one engagement, a fortified position embedded into a hillside, protected from aerial attack by its location, was targeted. A small number of rounds were fired. When observation resumed, the structure was gone. Not damaged, not suppressed. Gone. Events like this were not isolated. As operations continued, German units encountered the same pattern repeatedly. Positions that had been carefully prepared and concealed were identified and destroyed with precision. The expectation that terrain alone could provide protection began to weaken, and with it the ability to hold ground. Elite formations, including airborne and veteran infantry units, might begin to adjust their behavior. Some abandoned fixed positions sooner than doctrine required. Others dispersed their forces, avoiding concentration in reinforced structures that could be targeted. This adaptation, while logical, introduced new vulnerabilities. Dispersed units were less able to coordinate fire. Without strongpoints anchoring their defense, lines became less stable. What had once been a system of interconnected resistance began to fragment. The battlefield was shifting. As Allied forces advanced toward Germany itself, they encountered a defensive system that represented the culmination of German fortification doctrine, the Siegfried Line. Stretching hundreds of miles along Germany's western border, it consisted of thousands of bunkers, pillboxes, anti-tank obstacles, and fortified zones. Many of these structures had been built years earlier and reinforced over time. Thick concrete walls, steel doors, and interlocking fields of fire made it one of the most formidable defensive networks in Europe. It was designed to slow, if not stop, an advance. Previous experience suggested that reducing such a system would take time. Extensive bombardment, coordinated assaults, high casualties. But by late 1944, the conditions had changed. The 240mm Howitzer was now part of the operational toolkit. When Allied units approached segments of the Siegfried Line, they did not rely solely on traditional methods. Instead, they began to apply targeted fire against key positions within the defensive network. The process was systematic. Bunkers were identified through reconnaissance. Observation posts directed fire. Individual structures were engaged with a small number of rounds. Each successful strike removed a node from the defensive system. In one sector, multiple bunkers were destroyed within hours. Structures that had been expected to resist for days were eliminated in minutes. Infantry units advancing behind the artillery encountered fewer active positions than anticipated. The effect was cumulative. As more bunkers were destroyed or abandoned, the integrity of the defensive line degraded. Gaps appeared. Fields of fire no longer overlapped as intended. Command and control structures were disrupted when observation and communication posts were eliminated. German reports from this period reflected increasing concern. The issue was not simply the loss of individual positions. It was the realization that the system itself could not function under sustained precision attack. Some units attempted to adapt by avoiding permanent structures. Field fortifications replaced concrete bunkers where possible. Mobility was emphasized over static defense, but these adaptations came late, and often under pressure. The infrastructure of the Siegfried Line could not be easily altered, and once identified, its components could be targeted. The decisive shift was not a single battle, but a pattern repeated across multiple fronts: Italy, France, Germany. In each case, the same sequence unfolded. A fortified position held. It was identified. It was engaged. It was removed. With each repetition, the underlying assumption of fortress warfare weakened further. There was no longer any structure that could be considered inherently safe. No thickness of concrete that guaranteed survival. No terrain feature that ensured protection. For the defenders, this created a new reality. Positions that had once provided security now carried risk. The decision to occupy a bunker was no longer straightforward. Every structure became a potential target. Every strongpoint, once identified, could be eliminated with precision. This uncertainty spread through units at every level. And as it did, the nature of resistance changed. The war was no longer being fought solely through movement and maneuver. It was being shaped by the ability to locate and destroy, at distance, with calculated force. By early 1945, as Allied forces crossed into Germany and advanced toward the Rhine, the impact of this capability was fully established. Fortified cities, industrial complexes, defensive belts, all faced the same methodical reduction. The principle was consistent: identify, calculate, fire, and once fired, the outcome was rarely in doubt. At this stage, the question was no longer whether fortifications could be destroyed. It was how quickly and at what cost they would be removed, and what would remain once the structures and the confidence behind them were gone. Destruction measured, resistance broken. By the final months of the war in Europe, the impact of the 240mm Howitzer could be measured not only in individual engagements, but in accumulated results. Across multiple fronts, records were kept with precision. Artillery units documented targets, rounds fired, and outcomes observed. And these were not estimates formed after the war. They were operational data, recorded in real time as the weapon was used. The numbers revealed a consistent pattern. Thousands of fortified positions were engaged. The majority were either destroyed outright or rendered unusable. In many cases, only a small number of rounds were required to neutralize a bunker that had been designed to withstand prolonged bombardment. The efficiency was notable. Where earlier operations might have required extended artillery preparation followed by infantry assault, the 240mm Howitzer often achieved the same objective independently. A bunker that would have delayed an advance for hours or days could be eliminated in minutes. This reduction in time had consequences. Operations accelerated. Infantry units encountered fewer intact strongpoints. Engineers were less frequently required to approach fortified positions under fire. The need for repeated assaults on the same objective diminished. In sectors where these weapons were deployed effectively, the tempo of advance increased. The cost in terms of exposure began to shift. While the weapon itself was destructive, its use often reduced the necessity for close-quarters engagement with fortified defenses. This altered the distribution of risk on the battlefield. Instead of concentrated losses during assaults on bunkers, the destruction occurred at distance. For the defenders, the effect was different. Casualties from artillery had always been a part of warfare. But the nature of these casualties changed when entire structures collapsed under a single impact. Survivability inside a bunker, once considered high, became uncertain. In some cases, there was no opportunity to react. Reports indicated that losses from individual strikes could exceed those from extended periods of conventional shelling. This contributed to a broader pattern. As more units experienced the effects of precision-heavy artillery, behavior adapted. Some formations began to avoid occupying reinforced positions altogether. Others used bunkers only briefly, minimizing time spent inside structures that could become targets. This adaptation, however, came with trade-offs. Without the protection of reinforced concrete, troops were more exposed to other forms of fire. Field positions offered less durability. Mobility increased, but so did vulnerability. The balance between protection and exposure became more difficult to manage. In many cases, the result was reduced cohesion. Our defensive systems built on fixed strongpoints depended on those points being occupied and maintained. When troops hesitated to use them or abandoned them prematurely, gaps emerged. Coordination between positions weakened. Command structures, often housed in reinforced bunkers, became less stable when those structures were targeted. The system designed for stability became less predictable. At a broader level, the effect of the 240mm Howitzer extended beyond individual engagements. It influenced how operations were planned. Commanders began to incorporate super-heavy artillery into their approach to fortified areas. Rather than treating bunkers as obstacles to be overcome through maneuver alone, they were treated as targets to be eliminated before movement began. This shifted emphasis. Reconnaissance became more detailed. Identifying fortified positions was no longer just about situational awareness. It was a prerequisite for engagement. Once identified, those positions could be scheduled for destruction as part of the operational plan. This integration increased effectiveness. Artillery was no longer reactive, it was preemptive. Before an advance, key positions could be neutralized. During an advance, emerging threats could be engaged quickly. After an advance, remaining resistance could be reduced without requiring immediate close contact. The battlefield became more controlled, not in the sense of predictability, but in the sense that specific problems could be addressed with specific solutions. The cumulative effect of these changes was visible as Allied forces moved deeper into German territory. Like fortified zones that might once have slowed progress were reduced more rapidly. Defensive lines, even when well constructed, were less able to hold for extended periods under sustained precision fire. The expectation that fortifications would provide long-term resistance diminished. At the same time, the psychological dimension continued to evolve. As reports circulated among German units, awareness of the weapon increased. The knowledge that certain types of artillery could destroy even the strongest positions affected how soldiers assessed risk. Confidence in static defenses declined further. In some cases, this influenced decisions at the command level. Holding a position that could be systematically targeted carried different implications than holding one that could absorb punishment. The calculus of defense changed, not only in terms of physical survivability, but in terms of morale and sustainability. By the time Allied forces approached major objectives along the Rhine, the effects of this shift were fully established. Fortifications still existed. Bunkers were still built and occupied, but they no longer carried the same meaning. They were no longer assumed to be reliable, and in a war where belief in protection had once been central to defensive strategy, that change had consequences that extended far beyond the structures themselves: industrial power, doctrinal collapse, and the end of an era. By early 1945, the battlefield reality had aligned with a deeper structural truth. The effectiveness of the 240mm Howitzer was not an isolated achievement. While it was the visible outcome of a much larger system, one built on industrial scale, logistical depth, and coordinated execution. Every round fired represented more than a single act of destruction. It represented a chain, steel forged in American factories, components machined to precise tolerances, explosives produced, transported, and assembled, shells shipped across oceans, delivered through ports, moved by rail and truck, positioned near the front, loaded, calculated, and fired. Each step required organization, and each step functioned consistently. This consistency became a decisive factor. While other nations developed powerful weapons, they often did so in limited numbers. Some systems required extensive preparation, others depended on specialized infrastructure. In contrast, the American approach emphasized repeatability. The 240mm Howitzer was not unique in isolation. It was one of many units operating within a network that ensured it could be supplied, maintained, and used continuously. A single gun could destroy a bunker. A system of guns supported by sustained production could dismantle an entire defensive network. German forces, by comparison, faced increasing constraints. Material shortages, disrupted supply lines, and pressure on industrial output limited their ability to respond in kind. Even where comparable concepts existed, large-caliber artillery, heavily fortified positions, the scale and sustainability were different. Fortifications required time and resources to build. Once destroyed, they could not be quickly replaced. This created an imbalance. Each bunker represented an investment. Each shell that destroyed it represented a fraction of a larger, ongoing production process. Over time, the exchange favored the side that could replace expenditure more easily, and in this case, that advantage was clear. As Allied forces crossed the Rhine and advanced into the interior of Germany, the remaining fortified positions were engaged using the same methods refined over the previous year. Cities designated as strongholds, industrial complexes converted into defensive positions, pre-war fortifications reinforced for final resistance. All were subjected to targeted artillery fire. The outcomes followed a familiar pattern. Key structures were identified and engaged. Observation posts were eliminated. Command bunkers were destroyed. Defensive networks, already strained, became increasingly fragmented. In some sectors, resistance collapsed rapidly. Units that might have held positions for extended periods instead withdrew or surrendered after observing the destruction of nearby fortifications. The loss of physical protection combined with declining confidence reduced the willingness to sustain prolonged defense. This did not occur uniformly. In certain areas, fighting remained intense. Urban environments introduced new variables. Buildings, unlike bunkers, could be repurposed and occupied dynamically. But even in these conditions, the presence of heavy artillery influenced behavior. Structures that could be targeted were used more cautiously. Movement increased, static defense decreased. The shift was consistent with earlier adaptations, but now applied across a broader front. By the end of the war in Europe, the cumulative effects were evident. Fortifications, once central to defensive planning, had lost their dominant role. They were still constructed, still used, but no longer relied upon in the same way. The assumption of durability had been replaced by an awareness of vulnerability. Military doctrine began to reflect this change. Post-war analysis by multiple nations examined the role of heavy artillery in reducing fortified positions. The conclusion was not that fortifications were obsolete, but that they could no longer be considered inherently secure. Their value depended on context, concealment, mobility, redundancy. Static strength alone was no longer sufficient. The 240mm Howitzer contributed directly to this shift, not by itself, but as part of a system that demonstrated a new approach to warfare: precision over volume, targeted destruction over area suppression, integration of observation, calculation, and fire. These elements working together allowed specific problems to be addressed with specific tools. A bunker was no longer an obstacle to be endured, it was a target to be removed. The implications extended beyond Europe. Military planners in the post-war period considered how similar principles could be applied to future conflicts. Advances in technology would eventually change the methods: guided munitions, improved reconnaissance, faster communication. But the underlying concept remained: identify, target, eliminate. The lineage of that approach could be traced in part to the systems refined during this period. For those who had experienced it directly, however, the change was more immediate. German soldiers who had relied on reinforced positions encountered a reality where those positions could fail without warning. American crews who operated the guns understood the effect of each round, even if they did not see it. Forward observers, positioned at the edge of the battlefield, witnessed the transformation of structures into debris. Each perspective reflected a different aspect of the same process, a process in which material strength met calculated force. And in that encounter, the outcome became increasingly predictable. As the war drew to a close, the sound of heavy artillery did not carry the same meaning it once had. It was no longer just a signal of ongoing battle. It was an indication that a position, no matter how well constructed, could be reduced systematically and deliberately. And once reduced, it would not return. As in the long history of warfare, fortifications had always represented certainty. From ancient stone walls to reinforced concrete bunkers, the idea remained the same. Build strong enough and you can endure. Protection could be engineered. Survival could be calculated in thickness, depth, and design. For a time, that belief held. But in the final years of the Second World War, that certainty began to fade, not because fortifications disappeared, but because something else had surpassed them. The U.S. 240mm Howitzer did not introduce destruction to the battlefield. Destruction had always been present. What it introduced was reliability, a method by which even the strongest defensive structures could be identified, targeted, and eliminated with calculated precision. It changed the relationship between offense and defense. Its concrete no longer guaranteed safety. Steel no longer ensured survival. The battlefield was no longer defined by what could withstand impact, but by what could be located and struck. For the soldiers who experienced it, this shift was immediate. A bunker was no longer a refuge. It was a position that might hold, or might vanish without warning. The confidence that once accompanied reinforced walls gave way to uncertainty, and in that uncertainty, behavior changed. For the war itself, the implication was broader. The balance had moved, not toward a single weapon, but toward a system, one that combined industry, coordination, and precision. A system capable of applying force not just widely, but exactly where it was needed. And once that capability existed, the logic of static defense began to lose its foundation. Mind, the era of fortresses did not end in a single moment, but in places like Anzio, Monte Cassino, and along the Siegfried Line, it became clear that no structure, however strong, could remain untouched indefinitely. What had once been a shield became a target. And in that transformation, the nature of modern warfare quietly changed. Quietly changed. Quietly changed. Quietly changed. Quietly changed.